In this video, we're going to look at a couple of more advanced related rates problems. So here we have a water tank that has the shape of an inverted circular cone. So I'm going to here's a inverted circular cone with a base radius of 2 meters. So the base radius is going to be here, and we'll make that 2 meters, and a height of 4 meters. So 4 meters is our height. If water is being pumped into the tank at a rate of 2 meters cubed per minute, find the rate at which the water level is rising when the water is 3 meters deep. So here we have this inverted circular cone. There's some amount of water in here, so this yellow we'll say is the water. And I'll just draw like an extra little hoop-de-doo. There we go. So a couple things we want to make note of here. So this is an inverted circular cone. So there's only one formula that we could possibly use for this, which would be V for volume is equal to 1/3 pi r squared h. That would be the volume of an inverted, or a volume of a circular cone. Another thing to kind of notice here is that we have a radius at the base, which is 2 meters. As you go further down and it gets more and more narrow, the radius is going to get smaller as well. So unlike a regular cylinder that we looked at in the other video, when you have a cylinder, the radius throughout, put the R here and R here, is the same no matter where we go on the cylinder. But in a circular cone, what happens is the radius is going to get smaller or larger depending if you're going closer to the point or farther away. So depending where I am, let's just say right here, there's a radius of r and a height of h. Okay, so that will change depending on how much water is in here. So they're telling us that the water being pumped in pumps in at a rate of 2 meters cubed per minute. So that means that the rate of change of the volume, so dV over dt, is equal to 2 meters cubed per minute. Then they tell us to find the rate at which the water level is rising. So we want to find the rate of change of the height, so dH over dt. That's what we're trying to find, when h is equal to 3. So notice that it doesn't tell us anything about the radius. Like, we know the radius is 2 meters at the base, but we don't know anything about the radius, that as far as like the rate of change of the radius. When we had a question with the cylinder in the previous video, we talked about how the radius stays constant, so the rate of change of the radius would be 0. That's not true in this case, and we can see that as we change, the radius is also changing. Since they didn't tell us any information about that, what we need to do is change the radius to be in terms of the height. Right, so if I was trying to take the derivative of this, I would need to know something about dr over dt, which I don't know. So we're going to make a proportion. So the ratio of the radius to the height, we can see that the radius is 2 meters when the height is 4. So the radius at any point within my shape would be r, and my height would be h. Okay, so even though we're specifically going to be dealing with the height of 3, we don't want to put in the height of 3 until we've found the derivative of the volume. So we can cross multiply here, and we can say that, right, 2h is equal to 4r. So we're going to solve this in terms of r. So r would equal h over 2. So what we're going to do for that is we're going to plug that in. So we're going to substitute in h over 2 in place of r, okay, in our volume formula. By doing that, then we won't have to deal with any type of dr over dt that we don't have. So let's rewrite this volume formula. So volume is equal to 1/3 pi. Now instead of r, we're going to call it h over 2 squared h. Now to kind of clean this up a little bit, or simplify it a little bit, if I were to square this, I would get h squared over 4, and then I have an extra h. So when I multiply all this together, I really have 1/3 pi h cubed over 4. Okay, so I'm getting that h cubed from the h squared when I squared this times the additional h here. So now we can take the derivative of everything in terms of t. So take the derivative of the whole thing. So the derivative of the volume is going to be dv, I'll just write this like this, dv over dt equals, and then we have 1/3 pi h cubed over 4. So 1/3 pi is like our constant that's in front. So really we're taking the h cubed over 4, and you can even, if you wanted to, pull the 4 out and make it 1/3 times 1/4, so you'd have 1/12 in the front. Whatever kind of makes sense to you. I'm just going to leave it as the 1/3 because when I multiply the 3 using the power rule, 3 times 1/3, that's going to cancel out. So I'm just going to have pi h squared over 4. And then times the derivative of h, because if you think about this, the outer function is something to the third, and the inner function is that h. So the derivative of h would be dh over dt. So now, once we found the derivative, we can plug in stuff we know, and we're trying to solve for dh over dt. So dv over dt is 2, pi is pi, h is 3, and then dh over dt is what we're trying to find, so dh over dt. Okay, so we can multiply by 4, so we get 8 on this side, and then we can divide by the 9 pi to get dh over dt by itself. So dh over dt is equal to 8 over 9 pi. Or if you wanted to make it into a decimal, make sure that we use 3 decimal places. So you would say 0.283, so whichever way you want to use it. And then the units here would be, I'll just write them down here, meters per minute. So either 8 over 9 pi or 0.283 meters per minute. Okay, so let's look at another type of problem that's similar to that one, another cone problem. The AP test, they like cones a lot. So it's very possible you'll see a cone question on the AP exam. So a man is sipping soda through a straw from a conical cup. So again, same shape. We have this cone. So it's like one of these types of cones, and then he's got this nice little, what is that? My little straw. I know, you're welcome for my artistry. There's my little straw. And then there's some soda in here, so I'm just gonna fill that up with some soda. Okay, so same idea as the last problem, right? We've got 16 centimeters deep and 8 centimeters in diameter at the top. So we know that the height is 16 centimeters. And then in this case, they told us that the diameter is 8. So if the diameter is 8, then we know that the radius is really going to be 4 centimeters. Okay, so make sure you're paying attention to the units. So when the soda is 10 centimeters deep, he's drinking it at the rate of 20 centimeters cubed per second. How fast is the level of the soda dropping at that time? So same type of setup as the other problem, right? We're dealing with volume because we have a cone. So we have volume is equal to 1/3 pi r squared h. Okay, we're given dv over dt, the rate of change of the volume with respect to time. And since he is drinking it, that means that the 20 centimeters cubed per second, that means that the volume is decreasing by that much because it's coming out of the water's coming out of the cup. So this would be negative 20 centimeters cubed per second. And we're trying to find dh over dt. So that's what? When h is equal to 10. So like before, we don't have any information about the rate of change of the radius. So we first need to set up a proportion here. So we're going to say that 4 over 16, so the radius versus the height, is equal to r over h. So we cross multiply, so 16r is equal to 4h, and we're solving in terms of r, so r is equal to h over 4. So very similar to the last problem, we're going to take that h over 4 and we're going to substitute it in for the radius in the volume equation. So we'll say volume is equal to 1/3 pi h over 4 squared h. So to clean it up a little bit, we have 1/3 pi, and then h squared is going to be h squared times h, so h cubed over 4 squared, so over 16. Okay, so then we are going to take the derivative of each side. Okay, so take the derivative with respect to time. So we have dv over dt equals, and again, this is similar to the last problem. So I can multiply the 3 times the 1/3, which is going to go away. So I'll have pi h squared over 16 times dh over dt. Then we're going to plug in the information that we know. So we know that dv over dt is negative 20. Right, pi stays pi, h is going to be 10, and then dh over dt is what we're trying to find. Okay, so if we solve this and move everything around and get dh over dt by itself, you can either have the exact answer of 16 over 5 pi, or 1.019, and it's going to be centimeters per second. Oops. Okay. Here's another type of problem. So we have a man who's 6 feet tall. He walks at a rate of 5 feet per second towards a street light. So I'm going to draw this very wonderful picture for you. Whoop. So here's like I'll even make a little light here. Whee. Okay, there's my street light. And there's a man, and he is not going to look like the right size, but there he is. And he walks towards the street light. So I'm going to pretend that's a straight line. He walks towards there. The street light is 16 feet off the ground. So I'm going to mark it here as being 16 feet. And the man is 6 feet. So let's put him 6. It's hard to read, sorry. So he's 6 feet. So at what rate is the length of his shadow changing when he is 10 feet from the base of the light? Okay, so we kind of have to think about how shadows work here. So this guy, he's walking this way towards the light. As he gets closer and closer and closer to the light, his shadow is going to be behind him. So his shadow is the blue piece. His shadow, as he gets closer, is going to get smaller. So if we think about what shape this can kind of represent, this is going to be a really bad triangle. Pretend that looks good. Okay, so we have this triangle here. And really we have two different triangles, if you think of this. There's a bigger triangle and a smaller triangle. So we're going to call the distance from the man to the light post, we're going to call that A. And then the blue piece here, that's the man's shadow. We're going to call that B. So the overall big triangle base here would have a, I guess, distance of A plus B. If you're going for the whole base of the big triangle. So we want to find the rate of change of the length of his shadow. So what we're trying to find is dB over dt. The rate of change of B, so the rate of change of his shadow with respect to time, that's what we're trying to find. They're telling us he walks at a rate of 5 feet per second towards the street light. So this 5 feet per second, this is going to be dA over dt. So that's the derivative of, I don't know, A with respect to time. So like the derivative of his, the rate of change of his walking, I guess. So we see a triangle. And in the last problems that we looked at in the other video, when we saw a triangle, we did the Pythagorean theorem. But in this case, I don't think the Pythagorean theorem is going to help us right now because we're not trying to find the length of like the side that the light, like from the light to the man, like we're not trying to find the length of a side. We're trying to find the length of the shadow, which is like part of the base. So we have to think about proportions here. So whenever we have triangles, if you went back to the video where I had the different formulas listed, when you see a triangle, there are a couple different formulas you could use. So if you're dealing with the sides, most likely you're going to deal with Pythagorean theorem. But in this case, we're dealing with proportions. So we want to talk about the bigger triangle and the smaller triangle. So the bigger triangle is going to be the street light and the entire bottom here. So the one side of the triangle, in this case, would be 16 over the base of the triangle, which would be a plus b. So this is the leg, I guess, of the triangle and the base. And that is in proportion, so it's going to be equal to the little triangle that we have here that's created by the man and his shadow. So the man, the height of the man is 6, and then the base of that triangle is b. Okay, so we have the larger triangle is proportionate to the smaller triangle. Okay, so in this case, when we have a proportion, we're going to use cross multiplication. So I'm going to cross multiply. So I'm going to get 16b is equal to 6a plus 6b. And then I'm just going to make it a little bit simpler by moving the 6b to the other side. So I just have 10b equals 6a. So that's the formula that I'm going to be using. So this is what I'm going to take the derivative of. So I'm going to take the derivative with respect to time of this. So we've got the derivative of 10b is going to be 10 dB over dt, and that's going to be equal to 6 dA over dt. So then we're going to plug in the information that we know. So we've got 10 dB over dt is equal to 6. Now here's the thing, the rate of him walking is 5 feet per second, but he's walking towards the light, so he's walking in almost like a negative direction because he's approaching the light. So his rate is really going to be a -5 instead of a +5. And that matters because the length of his shadow is asking how it's changing. So his shadow is actually getting smaller the closer he gets to the light. So the rate of change of the shadow needs to be negative because it's decreasing. So he's walking towards the light, so he's walking -5. Then we plug this in, so we've got 10 dB over dt is equal to -30, and then dB over dt is equal to -3, and this would be feet per second. And what that means is that the length of his shadow is decreasing at a rate of 3 feet per second. So the question here is asking us, at what rate is the length of his shadow changing? So because it's saying changing, it's not indicating whether it's increasing or decreasing. So we need to make sure that we have the correct sign. So negative means that it's decreasing. If the question asked something like, at what rate is the length of his shadow decreasing? Then if it's already telling us it's decreasing, then our sign should be positive because it's just decreasing at a positive rate. So just pay attention to the wording. So if it asks just about changing, you want to make sure you have the correct sign and what makes sense in terms of the problem. Okay? If it asks you how it's increasing or how it's decreasing, then the sign should be positive. So just keep that in mind. Okay, so then we have one more type of question. So here we've got a fish is being reeled in at a rate of 1 foot per second from a point 10 feet above the water. So let's draw this out here. So we've got some type of dock here, and wooden planks, whatever type of dock. There's some guy, and he's fishing over here. Beautiful. And there's some type of I don't know, reel thing. I'm just gonna I don't know, whatever that is. Here's the water underneath. And then there's some type of, I'm really bad at drawing, so here's a fish. Oops. I'll color him in. So here's this fish. Whoops. This doesn't look like a fish, but pretend that that's a fish, because it is. He's fishing. He's catching this fish. So we've got 10 feet above the water, so this is going to be 10 feet 10 feet from here to here. And at what rate is the angle between the line and the water changing when there's a total of 25 feet of line out? So I'm going to just call this over here Z, and we'll use that in a minute. And the angle is that we're looking at is theta, which is this angle over here. So it's the angle between the water and the line. Okay, so let's make sense of this. So the fish is reeled in at a rate of 1 foot per second. So that means the dz over dt, because I'm going to keep it in terms of the variable I'm using. So z is the line, is the fishing line. So if I'm pulling in the fishing line, the rate of change of that is 1 foot per second. So that means that it's going to be negative 1 foot per second because the line is being reeled in. So the line is getting smaller, the line is getting reeled in, so it's being reeled in at negative 1 feet per second. They want us to find the rate of change that the angle is changing. So we want to find d theta over dt. So that's question mark. That's what we're trying to find when there's 25 feet of line out. So when z is equal to 25. So this is a type of question that we haven't necessarily seen yet. So again, we can see our little diagram that's a triangle. And it seems like, well, maybe I need to use Pythagorean theorem, okay? But I have an angle, and we haven't dealt with angles yet. So anytime you see an angle, you should think trigonometry. So what type of trig function can I use with this angle? So I'm using this angle, I have the side of my triangle that's opposite, and I have hypotenuse. I don't know much about the water side right now, so don't worry about that. So that means that we're going to use sine. So I'm going to say that the sine of theta is equal to opposite, which is 10, over hypotenuse, which is z. Okay, so this is the equation that I'm going to be using. To make it a little bit easier, I'm just going to rewrite 10 over z as 10 times z to the negative 1. I'm just going to bring that variable up, so it'll be easier to take the derivative of. Okay, so now I'm going to take the derivative with respect to time, okay, of this whole thing. So the derivative of sine of theta is going to be cosine theta times the derivative of theta, which is d theta over dt, equals, I'm going to use the power rule here. So negative 1 times 10 is going to give me negative 10 z to the negative 2 times the derivative of z, so dz over dt. Okay, so now if I go to try to plug things in here, I'm going to get a little stuck because I'm trying to find d theta over dt. I have dz over dt, and I have z, but I don't have cosine of theta. So we're going to create another little triangle over here and figure out what the cosine of theta is. So if theta is over here, and we have this side is 10, and they're telling us at the particular point when z is 25, so that side's going to be 25, what's going to be this side? So now we're going to use Pythagorean theorem just to figure out this side. So we're going to do like 10 squared plus b squared equals 25 squared, solve for b. So if we do that, we should get 5 square root of 21. So that's going to be the length of the bottom of my triangle. So if I'm using the angle of theta here, cosine is going to be adjacent over hypotenuse. So the cosine of theta is going to be adjacent, so 5 over 21, divided by the hypotenuse, which is 25. So here we can reduce the 5 and the 25 becomes 5. So cosine of theta is the square root of 21 over 5. So what I'm going to do is plug that into here. So instead of cosine theta, I'm going to call this square root of 21 over 5 times d theta over dt, which is what I'm trying to solve for. So we'll leave that. And that's equal to negative 10. I'm just going to bring this z to the negative 2. I'm just going to put it on the bottom. So it'd be z squared. And z is 25. So I'm going to put 25 squared on the bottom times dz over dt, which we know is negative 1. Okay, so if we just kind of move things all around, we're going to get that d theta over dt is equal to 2 over 25 square root 21. So you could kind of leave that as your answer, or again, 3 decimal places if you're going to use decimals. So this would be 0.0 either 18, or if you want to be precise, 175. And then the units here are going to be radians per second because it's an angle.